Thanks for having me.
All right. And this is our fourth event. We're really focused on, this series has been focused on IoT and the changes and challenges and hurdles that are bringing it all together. The plan here today is that we'll kick off with some opening remarks, and then I will hand it over to Danny. He'll be the moderator for the session and introduce our panelists and lead that discussion. I will gracefully step away or perhaps trip on my way out. That's very possible. And then I'll come back at the end to join you all. And we're going to, at the end of the session, have a move over to a networking session. So we'll go to, we can't do kind of breakout rooms in Zoom webinars. So we'll do Zoom Meet, and if that will give everybody a 30-second pitch to let us know what you're up to. I have a virtual wedgie app that if you're over 30 seconds, you will be the beneficiary of one virtual wedgie, which has worked very well. I think I've only had to give one in three episodes so far, which I was pretty bummed about, to be honest. But without further ado, I wanted to let you guys know there is an upcoming event with IoTerra, a product development conference coming up that Katie will be posting here. It's on November 16th from 8 to 5 p.m. There'll be 25 exhibitors showing off cool tech, 10 workshops, speaking events on hardware product development and how to scale development. And IoTerra knows this very well. They have the core team came from Breadware, one of the partners with us here at Hardware Massive and HardwareCon, where they exited their IoT development firm and have started an IoT kind of HR marketplace, a way to find solutions for IoT problems for enterprise and startups as well. So without further ado, I will pass it off here to Danny. And that link to that event is there in the product in the page, so you can check that out. And I will see you all on the other side.
Thanks a bunch, Greg, for introducing me and the company. And I'm really excited to talk today with the esteemed panelists here. I wanted to kind of preface this with a little bit of Wikipedia, some Wikipedia searching. Basically, I was just industrial IoT, we've heard so much about, and it's been such a buzzy word for so long, but I didn't really understand where it came from. So before we get started and I introduce Davis, Aaron, and Philippe, I want to just give you a quick Wikipedia history of industrial IoT. I did some Googling right before this. And so the history of IoT actually begins with the invention of the programmable logic controller, PLC, in 1968, which was originally used by General Motors in their automatic transmission manufacturing division. And then this kind of was the preface for it entering into the manufacturing chain. And then Honeywell in 1975 introduced a DSC, which was the next stop in allowing flexible process control throughout their plant. And then the Ethernet came along in 1980, and people began to explore the concept of networking devices. And the first one was a modified Coke machine, actually, in Carnegie Mellon University. So super interesting. And that was the beginning of this era. And then in 1999, RFID entered the field, and that was the true prerequisite for the Internet of Things, and objects and people in daily life began to be equipped with identifiers so that computers can manage and inventory them. And so today, we see tons of possibilities in the industrial Internet of Things, and we're hit with ceaseless inventory control, digital twins of entire production floors, enabling simulations without having to halt production or sacrifice safety, countless improvements in, oh my gosh, cybersecurity, cloud computing, AI, subtractive and additive manufacturing, M2M, advanced robotics, big data, IoT, RFID, AI, oh my gosh. So ton to cover, and I'm very excited to give the floor up to Davis, Aaron, and Philippe. And I'll just start with a brief introduction, and then we can kind of hit the ground from there. So starting, I think, with Davis. Davis Robertson is the head of research and development at Robotic Materials Inc. and is a full stack developer that has a ton of experience building robotic software solutions. So David, if you could say a couple words about yourself and give the introduction. Yeah.
Sure. So I've been working for robotics and manufacturing for a little bit. And what Robotic Materials is doing is basically developing software for integrating robotics into manufacturing environments, taking a data first approach and really finding where robots are useful and how to best integrate them in manufacturing environments. So I'm working with a bunch of manufacturers right now and developing specifically for their use cases and making sure that we can get IoT integrated as seamlessly and effectively as possible.
Awesome. Thank you so much. And Aaron, so Aaron is an expert in robotic lifecycle management with both Unity Digital Twin, and you're also an investor in deep tech. And Aaron has dedicated her entire career to advancements in robotics. So we're really honored to have her here. And she has a definition for a robot, which I'm taking from your LinkedIn, Aaron, but a machine or tool that reduces the physical strain of performing a manual task or performs a physical interaction that leads to operational efficiency. So Aaron, can you provide a little clarity there on that and then also introduce your background?
Certainly, yeah. I have degrees in industrial engineering and mechanical engineering from over 10 years ago, hailing from Boston. And I do define what a robot is because I want to make sure that whoever I'm speaking with about robotics, that we're speaking about the same realm. I'm not talking about any fictional Terminator coming to destroy the world. I am talking about machines and tools. These happen to be intelligent machines and tools. However, the purpose of Unity Digital Twins and robot lifecycle management is in order for these robots and tools to become smarter and better and do more complex tasks, they need to understand the context of the environment they are working in. And so in order to program them and make them smarter and train them and have performance improvement across all of these machines, you do need to have it exist in a simulation in order to test it and train it. And when that becomes available, more of the workforce can be supplemented, the dull, dirty, dangerous jobs. It's no longer a person breaking their own back. It's a person who is operating equipment and the robot does the manual task. And it'll be really nice if we have a workforce who do not need to injure themselves for their jobs.
Thank you so much, Aaron. And now Philippe, I'm honored to introduce Philippe. Philippe is the CEO of Topio Networks, which is quite a large network. It has a community of over 1.2 million professionals dedicated to the business of connecting things. And so, Philippe, please go ahead and talk a little bit about your background and welcome.
Yeah. So thank you so much for having me, and very honored to be working in this panel with Erin and Davis. I mean, you guys have a breadth of expertise in the space. On my side, I have a kind of a different background. I'm a venture capitalist by training, and about 5 years ago, I decided to jump on the dark side and become an entrepreneur. My area of expertise during the time when I was a VC was cloud computing and software as a service. I was an early investor in a lot of open source companies and a lot of software as a service companies very early back in the 1990s, actually. 5 years ago, I decided to leave the venture world and start Topio. And the reason was because the last 20 years have been about connected human to the internet, and it's very clear and we were seeing that with IoT at the time, that the next 30 would be about connected human. And what we've seen in the emergence of SaaS and cloud way back then, we're seeing now. We started with IoT, right? And we saw that a lot of the early implementation of IoT didn't go to production. And the main reason was not because there was a lack of ROI, but more because the cost of maintaining and the cost of implementing and maintaining the solution was too high. And what we've seen over the course of the last 5 years is we've seen the emergence of edge computing as a platform, and we're seeing now the combination of IoT and edge creating an environment where the team, the cost maybe is now affordable, and so you're seeing more and more applications being developed, and you're seeing those applications being completely different from SaaS and being distributed application, what we call distributed application or edge native application, which of course encompasses predictive maintenance, but robots and all those type of applications that are built specifically for the edge to provide the values that Daniel was talking about in his introduction. So fairly excited to be there, glad to be talking to people who are making this revolution happen, and glad to be with you today.
Thank you so much, Philippe. So I'd like to just kind of start right in to a kind of AMA type format here for this panel. So I have some questions for all of you, but I'd also like to just let the audience know that we can see any chat, and feel free to ask any questions to a specific panelist or to the panelists, and we will pop it up here and hit it. So I think I'd like to go ahead and start with you, Davis, and maybe before you answer the question, talk a little bit, just a little bit more about Optio and what Optio.cloud does and what it's about. Actually, that might be a good starting point. We'll go ahead and ask each of you to talk a little bit about your company as well before we get in here. But I wanted to ask you that, not, with regards to industrial IoT, where do you see industrial IoT applications being integrated, and why? And can you talk a little bit about why industrial IoT applications are needed?
Yeah, definitely. So Robotic Materials, which is now Optio, we started as a hardcore deep tech robotics company trying to sell robotic solutions to manufacturers, doing custom integrations. And the more we talked to these manufacturers, the more we kind of went around to them and tried to feel out their processes. They weren't interested, or when they were interested, they were interested for the wrong reasons. And so we kind of did this for a year and stepped back and said, okay, like what is going on here? Why aren't people interested in this? And what we found was that when people integrated robotics, all they were really doing was doing dumber things faster. They weren't really targeting the core of the problems in their manufacturing process, because they didn't know what the problems in their manufacturing process was. And so we took this robotic system that we'd been developing for the last year and kind of scrapped out a lot of the robotic focused stuff and geared it more towards optimizing a production system, and analyzing processes to give you the data that you need to make informed decisions about where IoT is necessary and where it's not. And so that's kind of what we've been focused on, is get this software system into a manufacturing environment and really let it, analyze the process, give the data to the user, and then based on that data, we can recommend, hey, this is your bottleneck station in this process. This is what's really slowing down your process. This is where you should be looking at integrating a robot, whether that's AMRs to transport materials throughout your process, or whether that's cobots to actually perform the tasks. And we found that that's really helpful. And so now we're kind of bringing the robots back into the fold and integrating these machines back into the software system, where we can even get the data from the robots and use that data to further optimize the process. So yeah, I think that's the main thing, is really identifying, where is it necessary and what can it actually do? Like, what are the limitations of certain systems? And how to identify where that's going to be useful to solve.
Awesome. And you mentioned just two things that I noted down, was transferring materials and then doing actual tasks. Can you give a little bit of maybe a use case, or just an example so that I can visualize it a little better?
Sure. So one example that we were talking to is Ball Aerospace, who has a bunch of little facilities around their factory that they are constantly transporting materials from one end of the factory to the other. And what they're currently doing is they have dedicated material handlers that their entire job is to walk around pushing these carts to different parts of the factory. That's one of these parts where you don't really need a human doing that. It's not a complicated task. It's an easy thing to automate. And so autonomous mobile robots have really come into play in a lot of these big manufacturing environments to, take materials from one end of the factory to the other. And that doesn't need to be on this large scale. It doesn't need to be these massive mega factories. It can be these smaller manufacturing facilities as well. And so that's one place that we're seeing a lot of automation and a lot of IoT. And then there's also cobots, which is kind of the more traditional robots that you want on your manufacturing floor. And that's what we're seeing a lot in the automotive industry. And those are a lot more customized. There's a lot more work, that upfront work that needs to go into actually programming those robots and making them effective. But I think when a lot of people think of, the pure industry 4.0, that's what they're thinking of, is these cobots that are automating every step of your manufacturing environment.
Okay, got it. So industry 4.0 doesn't necessarily mean that everything in the floor is automated, or does it? Is that what the definition of industry 4.0? I've always been confused about this, actually.
No, so it doesn't inherently have to be the idealized industry 4.0. Yes, everything would be optimized, everything would be automated. But it is really a true north conversation of, there's always more you can do. There's more automation, there's more integration, there's more optimization. And so you're always going to be chasing that true north. So anything you can do towards that true north, that's what industry 4.0 is really about.
Got it. Well, thank you very much. Thank you. And then we'll shoot over to back to you, Philippe, and then I'll go to Aaron. But can you explain a little bit more about Topio, the types of things that you guys do, the types of reports that you put out, and then also maybe my question for you is about the manufacturing floor today. Like, how siloed is it, or how integrated? I guess this kind of piggybacks on the question to Davis.
Yeah, no, it's a very, very interesting segue from Davis, right? So very quickly on my side, so Topio Network, we started Topio Networks about 5 years ago. As you said, we have a community of about 1.2 million business professionals. And what we're doing is we're tracking through an AI techniques as well. We're tracking all the technologies that are happening at the edge, right? And you mentioned some of them, right? So AI and edge computing and IoT, but you can also add blockchain to the equation. You can add data platform, and there are so many technologies that are being used that it's very confused to have a view of the market if you're just focused on one thing, right? So what we're providing is we're providing this overall view of how things are going to work together for which type of application. So we track the technologies, we track the infrastructure, right? So 5G, LP1, LoRaWAN, you name it, right? And we track on top of it all the applications. So industry 4.0 and industrial IoT is one of them, right? But we're also tracking smart cities, autonomous vehicle, all the different applications that are going to leverage that portfolio of technologies that we're seeing emerging now. So that's what we do, right? So we provide landscapes. So you can go on topionetworks.com, type edge computing, and you'll see all the companies. I mean, the meaningful companies that are associated with that market and where they are playing. So it's like huge, very nice 2D graphics that you can see. And then if you want to have more information, you get on the platform. It's available for free, and you can have access to a little card on each companies, little card on each market, where you see a lot of interesting information about where the market is going, as well as all the fundings and all the players. So that's what we do, right? And we have right now about 50 customers, AWS, Microsoft, IBM, so on the big one, but also on the very small one, right? We're helping very small companies positioning themselves in the marketplace for two reasons. One is there is a huge demand from Amazon and Verizon and Microsoft to actually develop those new edge native application and industry 4.0 application, right? There is a huge requirement for those applications to be started now, and so we're helping those big companies to do that, and then we're also helping those smaller companies to get to market, raise VC funds, and those type of things. So that's what we do, right? And to answer your question, I think the way to think about it is that if you're thinking about IoT, right? So what IoT is basically connecting objects to the network, right? So in the same way we were thinking about in the early days, right? If you're thinking about software as a service, people were uploading information into a database, and then you started developing application on top of that on top of that database. And guess what? You know, if you're looking at the amount of applications that have been developed over the internet, it's in the millions. Think about industrial IoT as the same thing, right? So we're connecting the device to the network, and we're gathering a massive amount of information. And so now what we need to do is we need to provide the platforms that enable people to have access to that information so that they can develop applications, right? And the type of application, sky is the limit, right? I mean, you've seen in mobile computing, you've seen on the internet, there have been so many applications that are now available leveraging that data that it's very difficult. And the only way you can do that is if you provide a standardized platform to enable to basically enable people to develop on the same format. And that's what we're seeing with hyperconvergence, right? So we're seeing now the cloud standard to come on premise, and people start developing on that. And we're seeing the integration of IoT with that hyperconvergence to create a unified platform that enable people to develop everywhere and run workloads on the cloud, on premise, in a gateway, or even on the sensors, right? So that's where we are going. Now, if you're talking about where we are now, it's a very siloed organization. Every application is being run on their own servers, so there is no unification. It's completely disaggregated, and so it's very difficult to kind of, you know, you have to build, if you want to build an application and access all the data that is stored in all those servers, it's very difficult to do. It's very difficult to manage, very difficult to maintain. So so it's a very difficult world right now. But yet, you know, if you're seeing stuff like what Optio is doing, you're getting to the core of it, which is you're building applications now that are running and can become the platform that people can integrate with their application and their device. So you know, I think we're getting into the right direction. It's just going to take some time.
Thank you so much, and thanks for providing some more clarity on Topio. It's fascinating how many different elements there are in this industrial IoT.
Yeah, absolutely.
Yeah. And I think for Aaron, I'd like to jump back a little bit towards robotics, and specifically, I think IoT and robotics are often said in the same sentence or with regards to the same topic, but how specifically does industrial IoT actually support these different robotic deployments? And then also, please do tell us a little bit more in general about your multiple different. Well, you also have an amazing reading list, by the way. I got to check that out on Goodreads. Oh. But can you tell me a little bit more about Unity?
Sure thing. Actually, what Philippe was saying about connected things and whether or not we have a central platform, like Optio. Maybe I'll back up a little bit, because there is an ecosystem to describe here, and how a lot of industrial IoT might be currently siloed. What Optio is building is that somewhat of also they're building a digital twin of the manufacturing floor, and in order to have an impactful view of what the manufacturing floor is doing, you need inputs. You need to know what's happening. And that's where these connected sensors are informing Optio on what is happening. Like there's products ready to move here. And instead of having a person having to witness this with their eyes and write it down and communicate it, these communications and these transport requests and task requests are generated in the platform. And the reason why I want to back up a little bit, especially for manufacturers who are new to process software, And they're going to, the first step into this is to look at process software, which leverages industrial IoT devices to interface with it. The whole reason is to have a better digital view of what's happening on the manufacturing floor, having those dashboards, having these timings. Instead of paper and pen and somebody walking around with a clipboard, you now have a digital sign. And that's very important for robotics. And Davis mentioned this segue. All manufacturers need to be thinking about their Industry 4.0 strategy. Labor shortage is becoming glaringly obvious now. Those of us in robotics, we've been seeing this on the horizon for the past 10 years. I'll honestly say, and I mentioned this at a CES panel 4 years ago, that I am confused when reporters are writing articles that robots steal jobs, when every customer is telling me I have labor shortage problems. These labor shortage issues are not new. They've been around 10 years. Now they are becoming glaringly obvious because we knew demographic inversion, retirement of the boomers, increase in demand for products and services there, and also reshoring. It's kind of putting a squeeze on everything. We want more and we have less. So we need this productivity gap to be met with industrial IoT and robotics technology in order to fulfill demand. And we see articles about this. Manufacturers are turning away business because they don't have the people on the floor to actually do this. And I emphasize this because it's important for any company who wants to start their industrial IoT journey or Industry 4.0 journey to communicate the why. And often the why is our business cannot make more money. We cannot fulfill more orders until we can do more with the staff we currently have. And that is a fantastic why. Otherwise, the business will not scale. And so what Optio is doing on where manufacturers are measuring their process is often the first time study step for a automation integrator. For people who come in and install robots, they also need to, because often if you install a robot, you actually need to change the process a little bit to accommodate the robot and need to get comfortable doing that. And so you need to understand what your flow is, understand the takt times for each process step, understand your bottlenecks, understand if you have any work in process buffer that's building up unnecessarily, understand downtime of certain machines. And when that is understood, you can make smart decisions on where to insert automation. This is where my company comes in, roboticsimulationservices.com. We're leveraging Unity. Unity is a video game engine. And I'm going to extrapolate a little bit backwards because there are a number of people in robotics who realize this, but many who don't. Self-driving car companies, about 5 or 6 years ago, self-driving car companies started doing some tests and some ML algorithm generation or even some behavior modeling or segmentation in the video game Grand Theft Auto. They took a video game where you drive a car around and crash into things, and they use that to train robotic self-driving cars. And Unity and Unreal and the game engine companies realize this, and now they're building many more tools along with NVIDIA Isaac, and they have now released more tools for robotics developers from the game engine point of view. Now, my company has actually been delivering those type of DevOps digital twin tools for continuous improvement on robotic arms for the past few years. So there's another set of tools required in order to leverage the suite of simulation tools that have been released by the large companies. And nobody who makes the video game for robotic forklifts, who makes the video game for collaborative robot arms. Well, that's what my team has been doing. And once a factory understands where they want to insert a robot, I'll put it this way: it's kind of like people in the Renaissance realizing, the sun does not circle around the Earth. The robot arm. Yeah, actually, I want to do.
Playback. I like it.
Yeah. The robot arm is not the center of attention anymore. It can't be. It's an interchangeable component to a system, and the system is modeled in a digital twin. And what the game engine tools are offering is photorealistic, fully plug and play simulation environments where you basically have a VR duplicate, almost apples to apples, of the experience. And then you can more easily operate, correct, train, communicate with various pieces of equipment on the floor. And so it's about machines talking to other machines. And then humans are getting dashboards to better interface with that information and make changes and model changes and do offline programming, so you don't need to take down your entire production line in order to change something. So yeah, I know it was a bit of a long answer, but I wanted to extrapolate that there are many small to medium manufacturers who are beginners of this process.
No, thank you. I could keep on listening. Actually, that's the most.
Can I add few things? Can I add few things on what Erin is saying? So
yeah.
the way I think about this, right? So I'm going to start with kind of the IoT and robots, right? You think about the concept of Russian dolls, right? So you have the device are embedded into objects or robots, right? And then the robots are embedded into machines, the machines are embedded into factories, and everything has to work together, right? And so when you're thinking about IIoT and robotics, right, they are one and the same, right? So robotics feed into IIoT and IIoT feed into robotics, right? So it's not like one just thing; it's everything all at once. And then the second point that I think Erin is making, that I think is clear, is this concept of digital twins. Is the fact that you're basically connecting device to an infrastructure, and because of that, you're able to create a digital representation of a shop floor that is updated in real time. So you can start doing simulation of anything, everything based on real life data. And that's going to create a lot of opportunities, of course, of game development, in order to enable stuff that happen in real life to become efficient, right? So you're going to be able to, when you're going to run simulation, you're not going to see this in spreadsheet, right? You're going to see actually the actual work of how it looked like, and the type of things that's going to happen in real life, in real world environment, except it's going to be modeled virtually. I mean, it's very mind-boggling when you're thinking about it, right?
And I think it's even more than that, because on top of just simulating an entire manufacturing environment, there's a limit to how much we can innovate on the hardware side. And we're starting to approach that asymptote where it's really a software problem. It's a machine learning AI training these robots to be able to do these things. You can't get enough data doing it in real life. You need a digital twin to simulate some of these actions that the robot needs to do. And same with changeover, right? If you have a manufacturing environment that's having changeover to produce a different thing every month, contract manufacturers, for instance, you don't have time to train these robots to do these things. You need a simulation environment where you can gather all that data and train it instantaneously, or maybe not instantaneously, but.
And Davis, to add to what you just said, which is absolutely 100% correct, is even today in autonomous vehicle, I mean, there is 1 mile of autonomous vehicle that is being driven in the real world for 100 miles of being driven in virtual environment, right? So, and we're going to see that with in the virtual manufacturing as well. You're going to see 100x more, the simulation being done for actually work that is going to happen in the shop floor. And it's really interesting to see how those two are going to work together.
Yeah. And thank you. So thank you everybody we have a couple questions piling up for specific and for the whole panel. But first I want to just real quick pop back and say thank you for nipping that question in the bud, Aaron, the robots taking over jobs question. I think that was the most eloquent way I've heard that answered, and I agree with your answer. But let's jump over to Davis. So we have a question from Mike too, and I'll go ahead and answer it here, we'll start answering it. Do most of your customers have pre-existing solutions for data collection on their line when you get involved? That's one. And then if you do, if not, do you guys help them set up with hardware, or are you providing APIs and letting them sort out anything lower level?
So pre-existing systems, yeah, we see a lot of systems, mostly like MES systems. NetSuite is a pretty common one that we see a lot. A lot of people are unhappy with them. They're kind of getting outdated, and even NetSuite we've talked to has some issues with them. So some people phase them out. Some people like to integrate on top of them and kind of get information from both. But yes, we definitely do see that, and we work with the customers to make sure they get what they need from both. And then as far as the hardware endpoints, so there are some that we integrate for you, and we're happy to discuss those options. We also have a fair amount of partners that are fantastic that we've worked with to help set up a lot of these endpoints for IoT and robotics as well.
Can I add very quickly on that topic, because it's a really interesting topic, right? So there is an entire IT organization that you're not aware of, and it's called OT, operational technologies, right? So there have been for the last 20 years, or 50 years, there have been people developing applications that were running on the shop floor, right? And those, so I would say a lot of the data is already collected into those systems. There are two problems with that. The problem is that it's not integrated, right? And the systems are not connected to the internet, and it was done on purpose because people didn't want their factory to be subject to security attack, right? So because of that, you have OT and IT, and so what you're seeing in the big companies is you're seeing those two departments coming together under one umbrella, and their goal is to really take everything that has been done in the OT level and bringing to the IT standard. So it's going to happen over the course of the next 3-4 years, but it's a big cultural change that the OT infrastructure has to undergo in order to become IT compatible.
Thank you. I think that actually also just forks right into a question from Ubidots about dealing with legacy systems, SCADA, PLCs, very old protocols.
So what people are doing today, right, is they are building systems that gather directly information from the device. So they are basically short-circuiting all the existing old protocols. So think about like a plug that you suck the data, but you're not dealing with the old infrastructure. That's the reason why you have all those applications. All those systems being built, and that's the way the connected IoT is all about that, right? It's about not leveraging the existing pipe to create another pipe in order to connect directly to the IT system.
Yeah, that's exactly what we do at Optio. Is we have a small Raspberry Pi or similar device that extracts the PLC data and then converts it to the IoT standards that we use.
Awesome. Thank you. Okay, I'd like to just jump back to what Aaron mentioned, because it's just very interesting to me. The video game simulation kind of environment, and you mentioned it too, Davis, about having people train systems or having simulations train the actual systems. Grand Theft Auto makes me think of like different things that are less and less complex. Driving a car is extremely complex, probably one of the more complex things that we could possibly do. But what are you seeing? Like how narrow is the scope? Can you automate just like one task and have it produce a positive ROI? Like what are you seeing there? And just before we jump, and this is an open question to anyone on the panel. For instance, one task is washing dishes. I actually have I have a friend. She's a mechanical engineer, doctor. Her name is Jessica. That works at a company called Dishcraft, and they're building automated dishwashing machines in San Francisco. So it's like super interesting to see all kinds of things that might not be industrial, but yeah. I'd like to just talk about that in an industrial standpoint. What are you seeing? What's the minimum threshold for automation?
Well, so I'm rather familiar with Dishcraft,
Oh,
and
cool.
I know the CEO. I follow the company's history, and maybe a good way to start, and the kind of machine that Dishcraft is building. Have you ever watched? If anyone has watched the YouTube video, I think it's How It's Made or some kind of manufacture large. It's all about the economics of your production run. And there are custom built machines for large scale manufacturing where they never change the production line. And those are very customized, very much you're putting lids on the jar, you're moving the thing specific way, and that system's going to do that forever. And Dishcraft is actually that kind of machine where they know what the size of the plates and the cups and the forks and the spoons, and they're going to be doing that in kind of a high volume type of machine. I'd say so there is a metric of automation costs, where usually it's if you look at a project budget, and I've heard this from a few automation integrators, 25% of the cost is the robot arm, 25% of the cost of the accessories like the gripper, the safety sensors, any kind of work cell type of structures, and then 50% of the cost is the programming. Now, those costs are coming down, but a manufacturer will do a very pragmatic analysis of whether or not this work cell cost will meet the ROI timeline of a year or less. And now so robotics is working down the chain from large scale custom manufacturing that never changes to manufacturing that might have turnover every year or two, to what about many CMs or CNC shops where their manufacturing lines change every 3 or 6 months. So the name of the game is getting that programming cost down. And in the past couple of decades, when it was very discrete, like this, I will program this robot to hit this weld point every time for a decade, that was feasible. That was an option, and those companies had internal robotics teams to program it, make sure it works, make sure it's running properly. But you think about self-driving cars, you cannot train self-driving cars to work in a discrete manner. You can't. It's not a discrete programming problem. It's probabilistic. It's going to change based on inputs and complexity and variation. It's going to react to collision control, or it needs to be more versatile, more nimble, because it's in a highly unconstrained environment. Now, if you take that same lens to programming robot arms, and suddenly you have a program, like a self-driving car is seeing objects in the space, it knows its position, it knows where it wants to go. Now, with the big difference between a self-driving car and a robot arm is a robot arm wants to collide with something one day. The grasp is a controlled collision. Yeah. And whereas a car is a little bit easier to program because you don't want to collide into anything, whereas a robot arm, you want that one controlled collision. So there's no reason today, and this is what everyone's realizing, that if you completely model the work cell in a 3D environment, I mean, SolidWorks is a good, and there are tools that do this, but they don't do the full stack. But you can go to a simulation tool, design your work cell, place the STL file of your part, place the robot arm, and it'll spit out the code for that robot arm for you.
Huh.
Yeah, those like Octopus, and they do this part of Vention. I think there's another one like that kind of exists, but if the part keeps changing or it is constantly reorienting from being placed in a bin, then that model somewhat breaks down. Or if it depends on if you need a new motion planning algorithm for every pick, and that's why companies like Ambi Robotics and Dexterity and Covariant are getting large sums of money from venture capitalists, because they're doing real-time fast motion planning for a new pick every time. So it really depends along that gradient of how much change is happening between every pick and every grasp request. And the more change required, the more you need the full contextual environment to respond. Now, and then if you have that full contextual environment, you can kind of easily extrapolate that programming a simple task would be very fast, very cheap, and not even leveraging the word programming. It's going to be drawn like an assembly is in SolidWorks, and you're going to say go. So that's kind of the way to think about it, is the ROI is getting more favorable for these small and medium manufacturers because the programming cost is getting smaller.
Yeah, that's fascinating. So what do you, I guess to the panel, and then after this question, we'll jump to Mike's question. And actually, we do have about 10 minutes left. So this is fascinating, and thank you so much. But what do you see coming? Let's say that these programs get better, these companies that are doing these fast, high variability programming get better. What's coming in the near and maybe far out? Just I'd love to hear from your three minds.
You have to choose who goes first.
Yes. Go
Hey,
for it,
yeah,
Eric.
I guess Davis, if you'd like to, yeah, what do you see coming in the near term?
Yeah, I mean, I think we're definitely going to see a lot more of this integration. As Philippe was talking about, it is really siloed now. I think we're going to see a lot more integration between these different aspects on a manufacturing floor, for one. And then I think the digital twin thing, it is going to become more common practice. It's going to become more commonplace as the tools get better. I know Isaac from NVIDIA was a huge push towards getting that more accessible. And so there's a lot of development going on there. Yeah, I think that's
Well, I'm 100% in agreement with Davis, right? So I mean, we need first to rationalize, to create that platform, and to rationalize all the applications that are on the shop floor, right? So I think this is happening today, and we need new type of application like Optio as well. So I mean, we're seeing that piece happening. The second piece is around the digital twin, absolutely, because we need the digital twin in order to implement what Erin is talking about. And the third one is robotics, right? So I mean, it's autonomous systems that can be developed and can do stuff already, right? So they don't have the full vision of what's happening around them, but they have enough vision that they can do stuff, and they are going to make progress as soon as more data is available for them. So I think those are the three pillars, right? And then after that, you have all the underlying technologies that need to evolve in order to do this. And if we go there, I don't think we are going to have enough time with 11 minutes remaining. So.
I think we are starting to see the future right now, especially since a lot of these game engine announcements have only been happening in the past 6 months, and NVIDIA. I think more about the small and medium manufacturers in the US who might, it's an insurance policy, and it's future-proofing your operation by getting that digital twin built now. And future workforces will have an easier time interfacing with it. Hopefully, retaining employees is easier because future employees will basically be interfacing with what looks like a video game.
Yeah.
but it's also retraining will be simple if there is turnover. And it's somewhat like, I don't know, like digitizing a paper photo album. If you want to keep these photos for the rest of your life, like paper photos are very vulnerable. And same way, like having a manufacturing plant that's only known by only people's heads know what it's about, or it's written down, or nothing's talking to each other, nothing's really fully documented. It's a very fragile place for it to be. And starting to move it into like a fully digitized realm. And I think about all these manufacturers who the owners are going to be retiring soon, or there is a large changeover, and things are lost in the knowledge transfer. This is a way to to keep that operation running. And what I stand for, the reason why I'm excited about digital twins and robotics and industrial IoT is the demand for goods and services in the US is going to keep going up, and we don't want to keep putting things on the water. So the manufacturing demand is here, and there's plenty of people who want jobs. So like, why is this a problem? Like we can have, and I know this audience probably realizes this, but a lot of people in the US don't even realize that we're still number 2 for manufacturing output in the world. We were number 1, China surpassed in 2010, but we make a lot of stuff, and there's no reason for us to lose that position for the US. And all we need to do is like put our systems into the digital realm so different people and new people can interface it and keep them going and keep optimizing them efficiently and growing them. It's good for business. So, end rant.
And, you know, just to add to what Erin was saying, and if you're a small and medium-sized manufacturer and you don't have budget to actually do what Erin is doing, if you look at all the applications that are running on your shop floor and you start rationalizing those applications, you're going to get huge saving. And with that money, you can start investing in what Erin is talking about, right? So, I mean, we're seeing right now in retail store, we're seeing right now people saying, I was running applications that were costing me 40K a month, and now I can do that with 8K a month, right? So those are the type of order of magnitude savings that you can get, and with that you can start investing into what.
And Optio is a very affordable start as well. I was looking at the website over there, Davis, and I'm like, what like $59 an endpoint? Like you can get something happening for Davis. Like, was it like $1,000 a month? Is that, or I don't know?
Yeah.
There you go.
Even less than that, 600 to start. I mean, yeah. I mean, we really want to make it accessible. It's about ease of use. It's about like getting these small to medium manufacturers to the level where they can continue to grow. Because exactly to your point about digitizing, I really like the game board example, right? If you have a board game, it's a board game because you can fit all the necessary components in your mind. You can understand everything that's going on. When it has to turn into a video game is when you have too many components to fit in your head and you really need them written down somewhere. And that's where manufacturing is getting. And that's where a lot of these manufacturers are crossing the line from small to medium to large scale manufacturers. And if you don't have that digitization in place already, you're really going to be fish out of water.
Yeah.
Actually, I want to. Oh, I saw a question on the chat, then I just want to jump on. How could digitizing or industrial IoT prove its value for small business owners? Two quick ways. One is minimizing waste. If you have one part of your production cell, not realizing that another part has downtime, it could be producing all this work in process and you actually never work that out. Or, you know, you've overproduced one part and you haven't ordered enough upstream in order to keep it moving, so you end up having all this awkward downtime, which would just mean less efficiency. Another one is the workforce part, where you know, either if you're supplementing your current workforce with more intelligence, or it's a faster to retrain, then you know you're spending money on recruiting and workforce and retraining. Anything that speeds up that process and makes them more efficient is a savings. I don't know if anyone else wants to add to that.
Well, I think
and quality control.
Sky is the limit, right? I mean, it's about collecting the data, so you can start implementing stuff like Optio, but there are plenty of other applications that are coming up, right? So in terms of saving, as you mentioned, right, it's those are the savings. There is a saving from the rationalization of your existing infrastructure. So that's one saving. Then you have, you're going to have a lot of opportunity to improve your gross margin by just the stuff that Erin was talking about and other stuff, right? So, it's just a beginning here.
And then last quick question with regards to trust and mistrust. Nowadays, with companies, I think this is more on adoption of IoT in the line. Do you have customers unable to accept storing their data on these online systems? or servers or robotic systems that are not their own companies. What are you seeing there?
It's a big.
Yeah. So
go ahead.
Philippe.
Go ahead, Davis.
All right. So, I mean, yeah, there's definitely security standards. FedRAMP is one that we come across a lot, which is the government standard for secure data on the cloud. But yeah, we also, there's people that don't want any cloud integration whatsoever. And so a lot of companies that serve manufacturers end up doing a hybrid system where they can completely offload their application to a local server as well. And I'm sure, Philippe, you've dealt with that a little bit, seen a lot of people who want their own on-site servers.
Yeah, I mean, I would say all of them are.
Yeah.
I think you need to start thinking about moving away from SaaS, right? To start thinking about edge native apps and the cloud being a service to those edge native apps, right? So of course there are going to be stuff that are going to be run in the cloud because there is not enough processing power on the shop floor to actually do stuff. But most of the stuff is going to happen in the cloud and in the shop floor, and the reason is exactly for what you're describing, the fact that people don't want to share their data, and so they want to be in control of their data. They are going to give to the manufacturer of the robotics. They want to give the data that they need and not more. And so there is a lot of conversation around that. Just to give you an example of that, Palantir and Airbus created a huge data warehouse to basically process all the data that is coming from the plane. And they were offering that as a service to all the airline manufacturers. And after 3 years, there is only 7 manufacturers that have signed up, and they are all tier 2. All the tier 1 have said, no, we don't want to share our data coming from the plane. So it's a big thing, right? And it's going to take some time for people to be accepting to share data like that. It's not completely obvious. Blockchain, by the way, can help.
That's another panel discussion.
Yeah,
Blockchain.
I know a guy.
We know that hiring us to drive cars safely in a video game. We should. Thanks, Greg, for stopping us back. But thank you, everybody, for this panel. It's been a lot of fun.
Hey, yeah, thank you, guys. I hope everyone had as much fun as I had. It was a super informative conversation. I appreciate the speakers. You guys have really been great. We cannot get applause in the way we're set up here, so we'll scoot over soon. But in lieu of applause, it's kind of my job to manage the applause for the room. So I'm going to say, wow, that was amazing. You guys were incredible. Wow, so great. Will you have my babies? Okay. No, they didn't say that. Thanks, guys. Really appreciate it. We have another great event coming up in a couple of weeks on November 10th. We have a panel. It's focused a little bit more around smart technology and reshoring. So we're going to have Nicholas Carell professor from UC Boulder, in robotics and computer science, Garrett Whitner, Hack's partner, Mike DeGrace from Universal Robots, and Ron Piper from Juxtum joining us for that. So join us for that if you can. We also, I wanted to, I just had one point. It's great having this stage sometimes. I can't help myself, but one point that I thought we could add to the conversation a little bit was that single solutions, we've just seen in the market that so many of these single solutions have not gained traction in IIoT, and it's there's just such a hurdle to getting into the market when you are only solving one part of the problem, and you have to then get the manufacturer to adopt to your technology, right? And so we've seen, I think this is the big disconnect with media and execution, is that media can show a beautiful robot doing beautiful things, but in reality, you look at a lot of these startups, and there just hasn't been that traction, that ability to convince a manufacturer to switch gears, for your particular solution, and mostly because it's hard, and so the reality is a lot of factors are still in Excel and whiteboards and paper, and that's really where it is. So the good news is that there's tremendous opportunity for U.S. manufacturing, really manufacturing across the board to make huge gains, and we are going to talk a lot more about it. So want to thank IoTerra. Thank you, Danny, for moderating today. Really appreciate it. And we're going to get your other co-founder, I think, in a couple weeks. Is that right?
Yeah, they'll come in and say hey.
Get to meet the team. All right. We have recorded this, so we'll send out the link with the videos and some sound bites and all that. So tell your friends, look it up if you want to remember about some key points. Thank you, Aaron, for the Grand Theft Auto enlightenment. I am not going to be riding in an autonomous vehicle for about 3 or 4 more years longer than I expected. And next, we're going to switch over to networking. So networking, we have a kind of a unique, cool way to do it. We switch over. Everybody gets the stage for 30 seconds, and then we'll see how many folks can make the switch. And depending on that, we'll split up into some smaller breakout rooms so that you're not stuck with a whole bunch of people. You can actually meet and greet and chat and do all that for a few minutes. And you'll also have the opportunity to put in your LinkedIn profile so that anybody that likes what you're talking about can meet up, and we can do this networking thing for real. So that link is in the networking session, or sorry, in the chat there. So click on that link. 3, 2, 1, go. And I will see you on the other side. Thanks.
Thanks.